to an equation. It makes the equation true whenever it's plugged in. Okay? So we will be testing solutions to determine if they are in fact a solution or not. Basically, this is telling us whether or not that point is on that line, if you're thinking about the graph. Okay? So one way you could check this is to graph the line and then see if the point is on that line. Let's do that with Desmos just to get a visual of what's happening here. You're gonna have to do these by hand, so you can't use Desmos, but just so we can see what it looks like. So if I graph y equals 2x plus 6 like this, and then I look at the point 5, 4, I want to see if 5, 4 is on that line. So from looking at this graph, we should already know what's the answer to this.
Wait, shouldn't it be 2x minus?
Oh, it should be 2x minus 6. This may change our answer. Oh, it does. All right, so let's look at this again. Is 5, 4 on my line?
Yeah.
It is. So that would tell me that this is going to be a solution. But we're not going to be able to graph these on Desmos. You can graph them by hand to check. That works as well. You're welcome to do that. Graphing by hand is perfectly fine. The other way that you can do this is that you can just plug in the points to see if it makes the equation true. Okay? Now, you're not solving an equation. You're just plugging in to see if the two sides are equal. Okay? So, to do this algebraically, 5 is my x-coordinate, 4 is my y-coordinate. So I would plug in a 4 right here for my y, and then I'd have 2, and for the x, I would put the 5 right there. And so basically, I just need to see if that right-hand side equals 4, and that would be 10 minus 6. Does 10 minus 6 equal 4?
Yeah.
Yes, it does. That is true, so this would be a yes. Okay. So if we're checking number 2, we've got -6, -5. So again, this is my x-coordinate, this is my y-coordinate. So I would put, where the y is at, I would put -5 equals 1/2 times x, which is -6, plus 3. So I want to know, if I do 1/2 times -6 plus 3, do I get -5? So what's 1/2 times -6? It's -3. Does -3 plus 3 equal 5? No, that equals 0. That is not true, right? So this point does not make my equation true. So that would be a no for that. If we want to think about what that looks like on the graph, I'm just graphing these on Desmos for the sake of time. If I graph, there's my line. If I graph -6, -5, oops, that's not right. -6, -5, you can see there's the point. It is not on the graph. Okay, questions? All right, let's look at a couple more where the equations look a little bit different, but otherwise, still it's pretty much the same thing. It says, which ordered pair is a solution to the equation 2x plus 5y equals 10? Okay, so if I want to know if something is a solution, I'm going to plug in my x and y and see if it makes it true. So here, this is my x, this is my y. So I would have, for this equation, I'd have 2 times 3 plus 5 times 1. And I want to see if that equals 10. In this case, it would be 6 plus 5 equals 10. Is that true? Oh, sorry. That is not true. That should be 11 equals 10. That is not correct. So A is not my answer. Hopefully B is my answer, or I've messed up this problem, right? So if I check for B, 2 times 0 plus 5 times 2 equals 10. So that'd be 0 plus 10 equals 10. Is that true? Yes. So B is my answer. Let's talk about what we've got to do if we want to do this one with the graph. Okay? Now, Desmos will graph this, but I'm not letting you use Desmos. I was just using it to save myself a little time there. So, if I need to graph this by hand, I cannot graph 2x plus 5y equals 10 by hand as it is right now. What do I have to do to 2x plus 5y equals 10 before I can graph it? For y. I need to solve for y, which will give me y equals mx plus b. Okay? So, Anna Grace, tell me how to solve this. Very good. We'll subtract that 2x. So 5y equals 10 minus 2x. What would I do next, Anna Grace? Good. Got everything by 5 there. So y equals 2 minus 2 fifths x. And so I'm gonna use Desmos again to graph just for time's sake. I don't want to spend too much time graphing it. I didn't give you a graph there to graph it on. So I've got 2 minus 2 fifths x, and if I look at the point I was checking 3, 1. Oh, why is it not? 3, 1, and 0, 2. You can see 3, 1 almost looks like it's on the graph, but if you zoom in a little bit, it's not actually on the graph, right? But 0, 2, you can see it definitely is there. Okay. All right, let's think about doing this next one. I've got x here and y here, so I can do this algebraically, or I could do it with the graph. Either way, I'm going to have to do a little bit of work. So if I want to do it algebraically, I would just do my y is 3 minus 7 would equal 2 times, in the parentheses here, I'd have negative 3 plus 1. So what is 3 minus 7? Negative 4. Over here, I need to do negative 3 plus 1. Good, and that'll give me negative 2. So negative 4 equals negative 4. Is this the solution?
Yes.
Yes, so this is probably my answer, hopefully. Right? 1, 7 should not work unless I've messed up this equation. So if I plug in here, this is my x, this is my y. So if I do 7 minus 7 equals 2 times 1 plus 1. Here I get 0 on the left-hand side, but over here on the right-hand side, I got 2 times 2, which is 4. Is that true? No, 0 does not equal 4. So A is the correct answer there. How do you graph that? What would I do if I wanted to graph that?
You would have to add 7 to both sides, doing up the negative 7.
I would, but before I can add 7, let's distribute that 2. So y minus 7 would equal 2x plus 2. And then I could add the 7 to that 2 over there. And so y would equal 2x plus 9. So if you wanted, you could graph that and check to see if the points are on there. Okay? Questions? All right, we, in a moment, are going to play a matching game. Delta Math is going to put you in groups. All right, so what you'll have are just some cards. And on the cards, you have points and you have equations. The equations are numbered. The points have letters. Okay? So, you will have, like, y equals 1/5 x minus 7. And you want to check and see if, you want to see which point is on that line. Well, there's 10 different points, 10 different equations. There are no points that are on more than one equation. So, so if you wanted to check B, you could either graph this and check to see if the point's on there, or you could take this point and plug it in, like we were doing algebraically, either one. And if it's B, then 10 goes with B. If it's not, you skip B, go on to another one, try another one. All right? So you're just matching, is this point on this graph? Okay, there's only one point on each graph. B would only go with number 3, or number 2, or number 10. There. So that's all you're doing. So you'll need actually you can just do it on the back of your notes. Go ahead and just number 1 through 10. You got 10 equations. Just number 1 through 10. And that'll be your record for your answers. We're going to get Delta Math to put you guys in pairs.